Hi folks, Mr. Long here, and this is the third in a series of 3 videos to introduce what's called the fundamental theorem of calculus. This time we're going to do a little bit of algebra as well, and not just graphical. The question is pretty simple here. I want to get the area under the curve from x equals 3 to x equals 4 down here, okay? And I'm going to do it with the graph to begin, but we're gonna go through this. So the first thing I want to do is I want to use this graph. So here's what I can see. Okay, here's what I can see. I'm being asked to figure out what is the area from x equals 3 to x equals 4 for this graph. Okay, so I want to get that area there. So I could compute it right on there. You know, I can do that. Like I can change this into a triangle and make that a rectangle and multiply it out. Because of the way you have to calculate areas with algebra later on, you can't really do that. So what you have to do with algebra is you have to take this graph, and break it down into a graph that goes from 0 to 4 and a graph that goes from 0 to 3. So let's take a look at this and let's shade in some things and see what we get. Okay, so I've got this 0 to 4. And then this one here, that would be 4 and 40. And so let's do this right here, and I'm going to shade this in. Okay. So is there a way that we can take this area here, okay, or determine this area here from these two graphs? Notice. So this is the area from 0 to 4. This is the area from 0 to 3. So how do I get the area of this from the area 0 to 4 and area 0 to 3? What would I do? You probably figured it out. You'd have to remove this area here, right? If I remove the area from 0 to 3 from the area that's 0 to 4, I'd be able to do it. Okay, that would be equal to this area right here, right? So let's see what that looks like in integral symbols. Okay, so this says here, get the area from 3 to 4. Now what we're going to do is, let's write this one. So this right here is equal to, we want to get the area from 0 to 4, f at x dx. That's that area, minus this area, which is the integral from 0 to 3, f at x dx. So look at this. You can notice something. If I want to get the area from 3 to 4, I just calculate the area from 0 to 4 and take away 0 to 3. Okay, and that's the method that we use all the time to do this. Okay, it's the method that we use. Okay, and it's actually a faster way to do it. So if you think here, it's just really two triangles, right? So for this one, what would the area be for this entire thing? Well, it's 40 tall and 4 wide. 40 times 4 is 160. Divided by 2 is an area of 80. This one here is 3 times 30. That's 90. Divided by 2, because there's a triangle, is 45. Okay, that means, and I've got to subtract those, right? So that means that area is going to be 80 minus 45, which is 35. So that tells me this little strip here is 35. Okay, it's 35. So what I need to do is now do some algebra. Okay, so by the way, the equation of this one I think is pretty easy. So it's a straight line. After 4 hours, the y value is 40. After 3 hours, the y value is 30. And the y-intercept is 0. So what do I do to x? What do I multiply x by to get y? How do you turn a 3 into a 30? How do you turn a 4 into a 40? Okay, so I think we know that this is going to be f at x equals 10x, right? That's this equation. By the way, this is little f because I'm taking the area of it. I mean, you can take the area of big F, but that's usually for average value. Just in this case, we're going to call it little f. Okay, so now I know the equation is 10x. So there is a formula here that we can use. Okay, this formula right here, so if this is rate, this is the accumulation formula. And we developed that in class, if you remember, and you might have forgotten, that's okay. Okay, so if the rate is x to the n, the accumulation is this relationship here, x to the n plus 1 over n plus 1. So we're going to start doing that. So I know that f of x is, the equation is 10x. What I want to do is I want to do the integral from 3 to 4 for 10x dx. Okay, so that tells me that, because it's f at x, right, is 10x. So this right here is what I want to calculate. And we can see that that's exactly what we were doing here, right? We're getting the area from 3 to 4 under the graph of y equals 10x. Okay, no different over here, right? This is the area from x equals 3 to x equals 4 for 10x. Remember, 10x is the y value. So this is your y value, dx is your x value. You'll multiply those together to get areas. But we're going to do it with algebra. Okay, we're specifically going to do it with algebra. And here's the thing that we know. Remember what we just did. We know that this is equal to the integral from 0 to 4 10x dx minus the integral from 0 to 3 10x dx, right? So that's what that does. So if I want to get the area from 3 to 4, I just get the area from 0 to 4 and take away the area from 0 to 3, and that's going to give me what's left over from 3 to 4. Okay, and I'm just going to put this here because sometimes we like these relationships with letters, but it doesn't matter. I could call that A, I could call that B, in which case that 4 would be B and 3 would be A, right? So the integral from A to B is the integral from 0 to B minus the integral from 0 to A. All right, so let's do our rule. X to the n plus 1 all over n plus 1. So that's going to equal 10x to the n plus 1. Well, that's 1, so that's going to be 10x to the 2 divided by 2. And then that's going to be evaluated. What we do is we put in here at x equals 4. Okay, then I'm going to minus off the integral here, which goes from 0 to 3. But it's still going to be 10x squared over 2, right? X to the n plus 1 over n plus 1. And now that's going to be evaluated at x equals 3. So what does that equal? Well, we know that 10 over 2 is 5. So that's going to be 5 times 4 squared minus 10 divided by 2 is 5 times by 3 squared, right? X squared. And I'm subbing in 3. Okay, so I'll just show you that here. So this 4 comes from here. This 3 comes from here. Okay. So again, this right here represents the area from 0 to 4. This represents the area from 0 to 3. Okay, 0 to 3. So what does that work out to? Well, that works out to 4 squared is 16 times 5 is 80, minus 3 squared is 9 times 5 is 45, and it's 35. Okay, and that, folks, is the integral from 3 to 4, 10x dx, okay, is 35. So that's the area between x equals 3 and 4. And you saw that we did it. We got this exact same answer of 35 with by just calculating areas. So we can use algebra, or we can do this. All right, so hopefully that helps, folks, and you should be good to go and be able to work through some of these questions on your assignment or any other homework that you need to do on area under curves, which is also known as integration. Okay, or antiderivatives, a lot of different names. Okay, have a good day.